we got to work out AY, right? So like I said to you to do in your, on that box, we're looking at this distance here, right? And we're looking for right angle triangles. So as you can visualize, if you look down through the top of the box, like you've seen, is that this is the right angle triangle, yeah? So on a diagram, it doesn't look very right angled, but that's why we kind of have to be able to visualize. Now, you told me that A to D is 5, wasn't it? It's over here. It's 5 centimeters. So A to D is 5. And then we know that this is 12, and we're told that X and Y are midpoints. So that would make that 6. So I think like you were just doing, then we've got our right angle triangle. So we've got 6, 5. So you did 5 squared plus 6 squared, square rooted. So 25 plus 36. So we've got the square root of 61 that we did. So what did you work that out as? 7.8. 7.8. Okay. So if I put that now, just as a, actually no, I'm not going to worry about it. I can put that as the square root of 61, which is 7.8 centimeters. I'll put it on my diagram. I agree. That's what you've got. So part B then, find the size of the angle XAY. Do you know where that would be? Because this is a tricky one for a lot of people to identify where XAY would be. So we've got X to A to Y. So from X, A, yeah, and then along the bottom to Y, yeah. So the angle that we want, now can you see that it is difficult to visualize, but do you see that the angle is actually kind of vertically up? So just to help you, it's not going to be quite right. If I put that down in there, that goes to the wrong place, right? It should be here. But if I then take that out, we're looking for this angle. All right. So what have we created again? We've created another right angle triangle. So there it is. You can imagine it being stuck in there. So now we do have a right angle triangle and we have an angle involved. So what are we going to use this time? Yeah, Sohcahtoa, trigonometry. And what do we need for Sohcahtoa? Well, as I've said, so we'll do Sohcahtoa, write the list, angle, opposite, adjacent, hypotenuse. The angle is what I want to know. So I'm going to call that X. Okay, do I know the opposite side? That's this here. Is it possible to know it? 6, that's the height. So I could put that 6 centimeters in there. What about the adjacent? Well, we worked that out before as 7.8. The hypotenuse is this length here. We don't know that. So which ratio am I going to use? So we can do the tan of X or theta is equal to opposite over adjacent. So we've got 6 divided by 7.8. And I'll let you carry on from that point. You can work it out. So on my calculator, we're going to do the inverse tan of, and I'm just going to put it straight in, 6 divided by 7.8, close brackets, press enter. I get that number. What do you get?
I get 37.6.
And who's right? put the same as me? Did you put the same as me, yeah? So who's right, you or me? Which one's more reasonable? What have you got? An angle of? All right, so look at the triangle that goes in your box. All right. I've got an angle, so yeah, you're looking at that bottom one. Is that angle more like 30 something or is it more like 0.6? So who's right? You. Why is mine wrong? Go on. I've done nothing wrong apart from one thing that you've got set up properly. No, there's nothing wrong on there. It's this, look. Press mode. I'm in radians. So that's what happens if I'm in radians rather than degrees. So it treats the angle as a number of radians. So it actually is the same answer, but given in radians instead of degrees. So I need to interpret that. But we don't work in radians. So if I now go back and redo my question, do exactly the same thing, look. 6 divided by 7.8. Press enter, I get 37.57, same as you, which is much more reasonable. So I did that to show you that you can, what was it, 37.6, wasn't it? Right. If you're in the wrong mode with your calculator, you can spot it because that 0.6 degrees is not reasonable. It's just not, it's not a feasible answer for this. So rather than thinking, oh, what have I done wrong? It might just be your calculator setup. All right. So I know it's not in this question in the book, but could I get you, please, to work out another length for me? All right. So I would like you to work out the length of the longest object that could be fit into that box. So what would it look like? So let's say, you know, I had, a long stick or something. What's the longest thing that you could fit completely inside the box? Where would it go? So could I fit something longer than the base? No? Well, that pencil's longer than the base, but if you turn it diagonally, it fits. Is there anything longer than that pencil that could fit in? What's the longest dimension in this box? It's not actually, because you put a pencil across the bottom, yeah? That's longer than 12, right? But there is actually another longer. That's why that triangle is created. That triangle in your hand is created to be the longest dimension in that box. You must have done it before. You must have had a box and thought, I need to fit something in it. So what's the longest that can fit in a box? Goes from one corner up to the other, right? So the longest dimension, you must have put a stick in a box or something. So if we go from one corner at the bottom, yeah, and go all the way across to this corner, that's the longest distance in this box. So could you work out that length? So we're going to use what shape? This triangle again. So we're going to kind of use this black one, but this time, like that one in the box in front of you, we've got this triangle. All right. But to work out this angle, what dimensions are we going to need? Oh, sorry, to work out this length, not that angle, to work out this length, what lengths do I need to know?
use the 5. I mean, no, 6.
Yeah, I can use 6, so that's 6 centimetres. This is the length I want to know, so I can put that as an X. So the other one that I need to know is, well, it's this one, isn't it? Is that 12? It's not, because that's where you put your pencil. And the pencil was 12, not, it was longer than 12. It came to about here and stuck over the box, but it did fit down. So you need to find that length as well. So you've got two things to count. How can you find that length? Well, if you think about it, again, if you look down in your box, what shape would that make? So if you put that triangle into your box and then look down onto it, is there another triangle? Do we know 2 lengths of the triangle to work out the third? Is that length shared by the blue one? So we need to work that out from the bottom triangle, and then we can use that. Now, are there any angles involved? Are there any angles? No. So what am I going to use? Yeah. Yeah, that's it. Go for it.